Should start sharing. Does everybody see my screen?
Yep, I can see it,
We
Jimmy.
do see it. Thank you.
Fantastic.
All right. Hey, everyone. Thanks for joining. My name is Miguel Cortiguera, and I'm a solution architect based out of here in South Florida. Been with AWS for about 1.5 years now, and I'm joined by my peer, Jimmy Martinez. Jimmy, if you want to say hello.
Yeah, definitely. Jimmy Martinez here. I'm also an AWS solutions architect, and I work alongside Miguel in helping South Florida customers build well-architected solutions on AWS. Happy to be co-leading this meetup on application health and recovery.
All right, Jimmy, if you want to take us to the agenda. So this is what we're going to go through today. We're going to talk at a high level first about disaster recovery and resiliency, just to kind of set the stage. Then we're going to go into the application recovery controller, which is a new service that we launched last year, and that's what we're going to be diving deep into and doing a couple of live demos for you today. Please do take advantage of the live demos. If you want to look at another screen or go back to something, anything you want to ask, if you're too shy to come on voice, you can use the chat, and we'll monitor that and help each other out as each of us are presenting. And then at the end, we'll share some resources, blog posts, some code, and open it up for any last-minute questions. So, Jimmy, I'll hand it back to you.
Excellent. So we'll start on the disaster recovery on AWS topic. And so ultimately, one of the fundamental roles of DevOps or operations is to ensure that applications continue to perform their intended business functions. And to achieve your business objectives, you must architect for resiliency. And when we think about resiliency, it's helpful to have a mental model like what you're seeing here so that you can distinguish from DR and HA. They are not completely separate. We know that the time spent down due to a disaster is an impact on overall availability. But the fact is that disaster recovery is an important part of your resiliency strategy, and it's your approach to restoring services when disaster strikes. This response must be based on your organization's business objectives, which will specify your workload strategy for avoiding loss of data and reducing downtime whenever your workload is not available for use. And so disaster recovery measures objectives for one-time events, like you're seeing here, while availability measures objectives for mean values over a period of time. And so let's take a closer look at HA. Availability itself focuses on one or more common disruptions of smaller scale, such as component failures. You could have network issues. You could have load spikes as well, right? And this is focused on preventing loss of service, which generally measures or is measured by the time an application is able to fulfill that business function. You should first ensure your workload meets your availability objectives, right? A highly available architecture will enable you to meet customers' needs in the event of availability impacting events. And it is more important to understand them as points on a spectrum, right? The key differences here being that HA is about preventing loss of a service and DR is about recovering from that loss of a service. And so availability is calculated by using mean time between failures and mean time to recover. And this approach is often referred to as the famous nines that we're very used to in our careers, where in this example, 99.99% of an availability target is referred to as 4 nines. But when we talk about DR, we are talking about business continuity, especially in the event of large scale but less frequent events. So we generally plan for these 3 main categories of disasters. You have those that are natural in nature, such as earthquakes or floods. You have technical failures, right? These can be power failures or even network connectivity issues. And you have human actions, right? Such as inadvertent misconfiguration or unauthorized third-party access that can potentially modify an environment or an application. And this is part of your organization's risk analysis, right? It's important to think about the risk that each of these actions has to business continuity and the impact that it would have if they were to occur. Each of these potential disasters will also have a geographical impact. They can be local, they can be regional, countrywide, continental, or global. And both the nature of disaster and the geographical impact are important when considering your disaster recovery strategy. An example I like to give here is, you can mitigate a local flooding issue causing a data center outage in AWS by employing a multi-AZ strategy, right? We know that availability zones are one or more discrete data centers. And so if we had a local flooding issue, it would most probably only affect one AZ, right, and not another. However, an attack on production systems might require you to invoke a disaster recovery strategy that fails over to either back up data in another AWS region or another instance of that workload spun up in that secondary region as well. And so we generally measure these rare events by measuring the amount of data loss as a unit of time, as well as how long it takes to become operational again. And these are better known as recovery objectives, and more specifically, recovery time and recovery point objective. And there are 4 typical strategies for DR, right? Each of these falling into a spectrum of recovery objectives and costs. To your farthest left, my left at least, you have backup and restore. And this is a strategy which comes at the lowest cost, but with higher recovery point and time objectives. And they're typically used for low priority use cases. Also under the active passive strategies here, you have pilot light and warm standby. And you can see that as you lower the recovery objectives across these strategies, they become more relatively costly. And you can see how you can begin to employ more stringent recovery objectives for business critical applications and services. And lastly, you have multi-site active-active on the farthest right. And with this strategy, you are aiming for zero downtime and near zero data loss. And these are fit for mission critical business services. One thing to note is that with near real-time recovery objectives will also come higher costs as compared to the other strategies that you see here. And so when designing applications, we have to keep in mind failures as well as performance, security, and other design aspects and principles, right? And cell-based architectures contain replicas for independent units of failover, and these can be switched on or off to isolate and contain those failures. And it can be particularly useful for partial failures or even performance issues to be able to toggle these replicas on and off. But to talk more about these cell-based architectures and how Route 53 Application Controller applies to them, I'll hand it back to Miguel. Miguel, off to you.
All right. Thank you, Jimmy. Can you see my screen there? Yep.
I do.
Yes, we do.
All right, great. Yeah, so the Application Recovery Controller is relatively new to the AWS portfolio. It was launched in July of last year, and it fits into that DR space that Jimmy was talking about. It gives you insights into whether an application and the resources are ready for recovery, and it also helps you manage failover. So as we dive deeper into it, you'll see how it ties into that cellular architecture that Jimmy showed in the previous slide. There's 3 key capabilities the Application Recovery Controller offers. One is the Readiness Checks. This is the ability to give you automated health checks to confirm if your replicas are able to take traffic. Next is routing controls, and this is the ability to redirect traffic to replicas. That's that on-off switch that you saw on top of each cell in that cellular slide. And then we also have the option of adding safety rules. These define and enforce failover criteria for routing control. So essentially, they safeguard you from making mistakes, for example, shutting traffic off to all cells. One thing to note is that the readiness checks and routing controls can be configured independently, so keep that in mind. One common question is, when would I use this service? And there's a couple common use cases. One is the mitigation of failures or partial failures across availability zones. So think of a scenario where your application is having an issue. It might be like a brownout issue or like a gray kind of issue where it's a performance problem. You're not exactly sure what it is. Or it could be an AWS issue in one of the availability zones. And you want to have that on-off switch to be able to control traffic, or you want to see if there's enough capacity in the other availability zones, if there's enough quotas and everything else is set up correctly to shift traffic over. The next use case is kind of the same thing, but at a multi-regional level. This is actually what we're going to demo today. The next use case is to be able to switch over traffic and recover within minutes. Now, a big caveat I'll put on this one is this switching assumes that your application is ready and able to take over on the DR site. And we're going to demonstrate that today. That's the ability to flip that switch and take the traffic over. So as long as your application is ready, within a couple of minutes, we can switch over that traffic. And then the last use case is, imagine today we're going to show you just a single application, but if you are in a larger organization where you have multiple applications, maybe you have those spread around different regions, different parts of the world, the application recovery controller gives you that single pane of glass where you can see if the applications are ready to switch over or not, and also have that on-off button where you can either through the console or programmatically be able to switch the traffic on and off. So let's talk about readiness checks. So again, a readiness check is a way to compare things like capacity, configuration, quotas, or routing policies, and make sure those are ready to enable switchover between one cell to another. Now, let's talk about the components involved in configuring these. We mentioned cellular architectures earlier in the presentation, and cells are one of the basic components of a readiness check. A cell defines your application replicas or independent units of failover. It groups all of the resources necessary for your application or group of applications together. This is a very basic example of two cells, and it's what we'll be showing in our demo. Now, one thing to note is that you determine the boundary of what a cell includes. It's typically an availability zone or a region, but you can also have more complex designs where, for example, here we have cells that are not only within an AZ, but then they're also nested in a region, and you can support more complex designs like this. Next, our resource set. So a resource set is a set of resources, including AWS resources that span multiple cells. These can be things like load balancers, auto-scaling groups, databases, VPN connections, etc. You'll see the full list when we do the demo. You can also have global resources like Route 53 health checks shown up here as part of the checks. And the next component is a recovery group. So the recovery group takes all of these different components within it. So the cells are within it, the resources are within it, and it represents the application or a group of applications that you want to have failover checks for. As you can see with our components here, it typically consists of 2 or more cells, and they mirror each other in terms of the functionality. So the readiness audits can include things like checking for capacity, configuration, quotas, the routing policies. For example, if you want to audit readiness for EC2 auto-scaling across 2 different availability zones, you can create a readiness check for that resource set with 2 resources, 1 for each auto-scaling group. And then the recovery controller manually monitors those instance types, the counts in the group, etc., to make sure that those are equal between the two before you initiate a failover. And that's exactly what we'll be seeing in our demo. So now let's take a look here at a real world example. I know all of you have very important applications out there, and I have a very important application here that's business critical to me. It's a tic-tac-toe application, and it's deployed across 2 different regions in AWS. So in US East 1, I have my active application, and then US West 2 is my standby application. And in a failure scenario, what I'd like to do is spin up additional instances here in US West 2 to handle that traffic. So my application leverages Route 53. We've got a load balancer in each of the regions. We've got the auto scaling group, and then we have DynamoDB. And DynamoDB is doing replication between the 2 regions to support that failover. So now what I'd like to do is configure readiness checks and set up these checks between them. So how do I do that? The first thing we do is we configure a recovery group, and this is very simple. It just gives it a name and essentially a bucket to configure all of these other things within it. Next thing we do is we configure our cells. In this case, pretty straightforward. I'm going to have a cell for each region that I support. Remember, these can be at the region or AZ level. And then the last thing we do is we configure our readiness checks between the 3 components that I mentioned. Now for the demo, what I've done is I've already configured a recovery group, and I have 2 health checks going, one for the load balancer and one for the database. But I did want to show you all how to configure a readiness check from scratch. So I'm going to go ahead and do that. And then we'll see if everything is running and if I'm able to fail over and support my users between the 2 regions. So I'll take a quick pause here and see if there are any questions.
So I had posted one on the chat there, Miguel. I was just curious if any of the participants here today are currently working on any DR initiatives.
Okay, yeah, that'd be great to know. All right, so let's go forward with our demo here. So I am here in the AWS console, and you can get to the application recovery controller either directly or you can go through Route 53. I'm going to click on the direct link here. And what you'll notice is it's under Route 53. And if you scroll all the way to the bottom, there's a new section that's been added here in the last year to support it. If I look on the main page, it's got all the resources you'll need there in terms of like the developer guide, getting started, API references, etc. Also, if you click on getting started, it's got a nice visual representation here of what all the components are and the steps to configuring those. So mention the 2 different features it mainly supports, the readiness checks and routing controls. So we're going to go ahead and go into readiness checks here. And what you'll notice here is that I have a recovery group configured. So this is my tic-tac-toe application. And I can view this by cell as well. So you can see my 2 cells here, US West 2, US East 1. They're ready. My recovery group is ready. And what you'll notice below here is I have 2 different readiness checks configured. I have one for my load balancer. I have one for my database. If we click in on one of these, you can see the specific resources that I have defined here. The resources are designated as ARNs, Amazon Resource Names, and these are specific identifiers that are given to each instance of a service that you configure within AWS. So now we're missing something, because I remember I mentioned that we wanted to do a readiness checks for our auto scaling group. So I'm going to go ahead and configure that. Now before I do that, there's 2 things we're going to need, which are the ARNs for each of my auto scaling groups. So I'm going to go ahead and open a couple tabs here. I'm going to open one tab, and I'm going to go ahead and go under EC2. I'm going to start with US East 1. And you can see that I have 2 instances running there supporting my application. Later on, we're going to share with you the URL for anybody that wants to play tic-tac-toe. But here I'm going to go into my auto-scaling group, and you can see I have one here. And I'm going to get that ready because I'm going to need that ARN. And then what I'm going to do is I'm going to open up another tab, and we're going to do the same thing, but I'm going to switch the region. So I'm going to go to US West 2, and I'm going to come over to EC2, and I'm going to go to my auto-scaling group there. So now I'm at the page here where I can access both my ARNs, and I am back at the Application Recovery Controller service page. I'm going to go ahead and say create here. The options here are a recovery group. This is if I wanted to create a recovery group for another whole different application. But in this case, I want to create a readiness check. And I'm going to call this tic-tac-toe. This tic-tac-toe auto scale group readiness check. And now here's where I select the resource type to check. So if I scroll up and down here, you can see all of the different services that we support within AWS today that I can create readiness checks for. So everything from like VPN connection, VPCs. These could be handy if some of this infrastructure you're going to be spinning up services in or adding capacity to it during a DR event. And again, you want to make sure that those two sides are equal before you flip that switch and send your traffic over to the other cell. So in my case here, I am going to pick auto scaling group, and we'll go next. And here I specify a resource set. If I had one that was built, I would be able to select it here, but since I'm creating this from scratch, we're gonna say that we want to add a new resource set. And the resource set needs these ARN identifiers. So what I'm going to do is give this a name. So I'm going to call this tic-tac-toe ASG resource set. Something meaningful. And then here's where I'm going to grab my 2 ARNs. So I'm going to flip back to the first tab here. I'm in US East 1. And I'm going to grab the ARN for my auto-scaling group here. I'm going to drop that in there. And then I am in US West 2, and I'm going to grab that ARN. And then we're going to come back and paste that in here. So this is something that I would do for each resource I want to check. I'm good, want to click next. Here's where I see the rules that are going to be in play for this type of resource. So what it's going to be doing is going to be checking that I have the same number of instances, the same type of instances, the same capacity. Again, if the concept here is that these cells are the same and I'm going to switch traffic, I want to make sure that the sizing is the same to be able to support it. And also one important note here, if you look at the last one here, this also checks service quotas. So this could be an important one. If you requested service quota increases, you want to make sure that those are configured in the other region as well. So I'm going to click next here, and now this is where it all comes together. So I have my 2 ARNs here, and here is where I tie that to the recovery group. So I'm going to say that these 2 resources and the checks are part of my tic-tac-toe recovery group. And then on the right-hand side here, this is how I tie these to which cell they belong to. So pretty easy because the resource name has the region in it. So this is going to be part of my East region, East 1 region. And then this resource over here is part of my West region. And then I click next, and it gives me a chance to review everything. So I've got my name, it's an auto scaling group, I have my 2 resources, I've got the rules, and I've got the cell. And I'm going to go ahead and create that readiness check. At the beginning, this is going to be in an unknown state. It takes it about a minute or so for it to check the readiness status. So this is a great time if anybody has any questions or wants to see anything in these screens here. Everyone is quiet out.
I'll just, I guess I'll just repost Patrick's question, right? It was a good one too. And what he was curious about was potential serverless use cases. So, having API gateway versus an ALB or EC2 instances. So, but I think you showed it on the console as well, Miguel, right? The API gateways, Lambda, these are supported resource types.
Yeah, API gateway is definitely one of those. And I know that we're going to be adding more resource checks here. So if you're working with AWS or working with a partner or us directly, and you have a particular use case that's not served by these checks today and you want to get it covered, then please reach out to your AWS contact or your partners so that we can get that prioritized. All right, so if you notice now, I did a refresh here, and now we have a status. My readiness check is there, but it says not ready, and therefore my application is not going to be ready. So this tells me, hey, I shouldn't flip that switch of traffic that Jimmy is going to be showing you in the next demo, because these two things are not the same, and if you expect to have the same capacity in both of your cells, it's not going to work out that way. So let's click on the readiness check here and see what's going on. What the readiness checks tells us here is that these things are not the same. So our capacity is not the same, and then our group size is different. This could be the case if we were running like in that warm standby model that Jimmy showed and the different DR models, where maybe I had a little bit of capacity running, but I needed to scale up during a disaster. So let's go back and look at our tabs here where I have my auto scaling group. And if you notice the one in East, it's got a desired minimum and maximum of 2. But if we go to the one that's in West 2, notice here that we've been running with a capacity of 1. And that's exactly why these checks fail. So now let's go ahead and change that capacity. And what we're going to be doing here is, of course, we're going to be spinning up a new instance to match the capacity. There it goes. So we have an instance coming up. And now what you'll see in about a minute or two is when we come back over here, if everything is working well, our readiness check is going to be able to pass. So one more pause here while this churns in the background. Any questions? One thing I'll take the opportunity and mention here, and I'll share the links for later, is that you can configure this manually like I'm doing here, but you can also use CloudFormation or Terraform, and I'm actually going to share the links of the sample code out there, as well as a blog post for anyone that's interested in doing that. You can get your own tic-tac-toe application running. All right, so I've refreshed this, and look at that now. All my readiness checks are good. If I refresh the application itself, that'll come up ready for the whole recovery group. So now I'm ready to flip the switch and do my DR changeover. And with that, Jimmy, I'll hand it back off to you to show us how that's done.
Excellent.
Let me go ahead and share my screen.
And so before diving into the second part of the demo, I'll touch on routing controls and safety rules briefly. So to failover traffic to application replicas in Amazon Route 53 application recovery controller, you use routing controls that are integrated with a specific kind of health check in Amazon Route 53. Routing controls are simple binary on-off switches. They're grouped in a control panel and are hosted on a cluster in Route 53 ARC, and that controls the routing of the client traffic. The traffic rerouting is accomplished by the routing control health checks that are set up with those Amazon Route 53 DNS records. So, for example, consider a DNS failover record. This is associated with a domain name that front ends your application replica and should have a health check associated with it. And I'll show you in the demo what that'll look like. But when you work with several routing controls at the same time in Amazon Route 53 ARC, you might decide that you want safeguards in place to avoid unintended consequences. Miguel was touching on this earlier, right? And an example here is that you may want to prevent inadvertently turning off all the routing controls for an application, which would stop all traffic flow, resulting in a fail open scenario. So you can configure safety rules with a combination of routing controls, rules, and other options that you specify. And each of these safety rules is associated with a single control panel. But just something to keep in mind is that a control panel could have more than one safety rule. A control panel groups together a set of related routing controls, and you can associate multiple routing controls with one control panel, and then create safety rules for the control panel to ensure that the traffic redirection updates that you are making and that the rest of your team are making are sure enough safe. So an example here is that you could configure a routing control for each of your load balancers in each availability zone and then group them in the same control panel. Then you can add a safety rule that makes sure that at least one zone represented by a routing control is active at any one time. And so a cluster is a set of 5 redundant regional endpoints against which you can execute API calls to update or get the state of a routing control. Something to keep in mind here as well is that you can host multiple control panels and routing controls over one cluster. And we do have some documentation on that, based off of like quotas, right, and how each apply to each other. And so what you're seeing here is just a representation of those 5 regional endpoints that you can use for setting and retrieving routing control states for each of your ARC clusters. And your process for accessing the endpoints should assume that ARC is regularly bringing these endpoints up and down for maintenance. So you should always try each endpoint in succession until you connect to one, right? If you are unable to connect to one, the likelihood of maintenance occurring in that region is possible, right? And you can access the endpoints to get the current state of the routing controls, again, whether they're on or off. And this will allow you to trigger failovers for your applications by changing those routing control states. Something else that's important to note here is that the cluster operates on a quorum model. So this means that that cluster and the routing controls continue to function and provide those failover controls and capabilities, even if up to 2 regional endpoints are unavailable. Routing controls can be integrated with health checks in Route 53. The health checks are associated with DNS failover records that front each application replica. So this lets you control traffic to your replicas by updating those routing control states. Another note here, right, is that these health checks are not actually triggered by health, but by the routing controls themselves, which are managed by you, the AWS customer, and I'll show you that shortly. And so what I'm going to dive into now is, again, back to that tic-tac-toe application, and we'd like to add some routing controls and test the shifting of traffic between those regions. The first thing that we do here right, and that we had to do to get our environment up and running is we had to build a cluster, right? And that cluster is going to give us that highly available data plane with individual API endpoints in 5 regions. This is going to allow us to make those routing changes in Route 53, even if the control plane is impacted by a large-scale event. We then build our control panel with the same concept of the different cells to route traffic to, and this is tied into that cluster that you create. And then last and most importantly, we built the routing controls, which let us switch traffic on and off to a cell. And these are tied to Route 53 health checks, which you control manually or programmatically. And this is just a quick glimpse at how safety rules are applied across the architecture. So let's say you created an assertion rule stating that at least one routing control needed to be on. If you tried to execute an API call and that tried to, let's say, rule your routing controls in region 1 off, right, you would get a nice validation exception error because of that safety rule. And I've got this all built out in the console, so I'm going to stop sharing here and then and navigate us to the Route 53 management console. And so sure enough, what we're going to do here is I'm already in the application recovery controller management console, and I'm going to validate the routing controls that I've already created here beforehand. So if I go and I click on the routing rules here, I'm sorry, the routing control, what you're going to notice is I already have a control panel built. This control panel is associated to the cluster that I have built here. This is my tic-tac-toe cluster. And when I go into the control panel, right, I already have these routing controls set. One routing control for each region, right? Both of these are currently in an off state, which is fine. And then if I click on any of these controls, well, what you're going to notice is that there's a health check ID associated to that. Right? If I click on that health check ID, sure enough, it's associated to a Route 53 health check. And what I'm going to want to do now is I'm going to want to associate that health check with that DNS or with the DNS records of my tic-tac-toe application. Now, what I'll do here is I'll post a link to the tic-tac-toe app. You can go ahead, right? I'll go through the login process now, create a game, and me and Miguel start our own tic-tac-toe competition here. But feel free to browse through, check out the region that you're in. You do need 2 players to play. So if you know somebody here today, go ahead and partner up with them and just ask them for the username that they created. But back to Route 53 DNS management console. I'm going to go to the hosted zone that's hosting that URL or the DNS for that URL that I just posted here. And I see here that I have 2 failover records, right? That's the route policy that I'm using. I have a primary and a secondary. And what I'm going to do is I'm going to edit the primary record and I'm going to associate the health check that I've created and that I know is associated to the control panel routing control for that region. So I'll select US East 1 for that US East 1 record, which is my primary record. And I'm going to go ahead and I'm going to edit that secondary record here. And then that's going to be US West 2 associated to that US West 2 record. I'm going to save that. And what I'll do is I'm going to go back to my routing control. And I'm going to turn that routing control on to my primary region and make sure that we have a production scenario here, right? We would always want one of these control states on, and we're all good here, right? So Miguel, I'm going to go ahead and I'm gonna sign up here.
And if everybody notices up on the top left, you see tic-tac-toe and it says US East 1, so that's the region we're being served out of. And
Absolutely. So I'm going to create a game here.
All right, and I'm logged in already, so you can invite me.
The names are case sensitive, right? So if you are deciding to play with somebody, make sure that you know how you spelled it.
All right, I see you there. All right, so here I go. Play some tic-tac-toe.
Excellent. I'm the worst tic-tac-toe strategist, so I'm sure Miguel's gonna take over.
Evening here.
All right. So what I want you to consider right now is a scenario where you're let's say a site reliability engineer, and your monitoring systems now have detected that the players of this uh, mission critical business service, right, and application, uh, well, they're observing errors, right, and your initial investigations are inconclusive. You don't know what's going on, but what you do know is that you need to alleviate this issue for your customers and reduce that impact while you try to find the root cause. And so you've made a decision already. You're going to fail over to your secondary region, and I'm going to go in and I'm going to do just that. I'm going to update those routing controls, and I'm going to fail over to US West 2. So, like Miguel mentioned, right, we were on US East 1. That's where we started our game. And this is going to be just as easy as now that we've got all that good stuff set up in Route 53 and in our against our DNS records and associated to our controls. I'm gonna come up here to Application Recovery Controller. I'm gonna hit up on. I'm gonna click on my routing controls, and then in the panel, I'm just gonna go ahead and I'm gonna make that switch. So I'm gonna select both of these. I'm gonna change the routing control state, and I'm gonna turn on US West 2, and I'm gonna turn off US West 1, and I'm gonna confirm that action. While that's failing over, I do want to navigate to a CloudWatch dashboard that Miguel and I put together here. And in this dashboard, what we'll try to observe, right, and monitor is the traffic going to the respective load balancers for our application architecture. So in this case, we still have or we're still showing, right, the higher number of requests into our US East 1 application load balancer, right? We're above 150 here, and still no traffic being observed to US West 2. Something to keep in mind here is that, obviously these are DNS records. You are bound to the TTL, but in our case, should be 60 seconds, right, to kind of update and take effect here. And so what I'll do here is let me go back home. I still have a game here. I'm in US East 1. Let me try an in private browsing window. See if that helps. And so fantastic, right? Looks like I had some browser cache there, but I went to that same URL, and now all my traffic is on US West 2. This is my failover region, and I'm gonna log back in. Sure enough, there's my game with Miguel. Let me click that. And Miguel, we should be able to pick up where we left off.
I got it here too. Let me log in again. All right, game's in progress. All right, there I go.
That's it. Checkmate.
All right.
Awesome, guys. So let me minimize this. I'm gonna go back to that CloudWatch dashboard and let me refresh. So I'm still not seeing that traffic displaying within my traffic monitoring. But this should come in shortly. What I do want to show you, so we've already verified that we failed over, right? While that's coming through, I want to go ahead and create a safety rule, right? So right now, I technically I don't have any guardrails. Somebody, maybe an SRE, right, that doesn't know another engineer or somebody that has access to these routing controls can come in here and just turn that routing control state off and potentially put me in that fail open scenario that we were discussing throughout the slides. So I'm going to add a safety rule right here within that same control panel that I'm in. Again, under application recovery controller, routing controls in that tic-tac-toe control panel. Because I do want to associate the safety rule to this control panel. I'm going to choose an assertion rule. You do have two types of rules to choose from. And in my case, I'm just going to go ahead and call this safety rule prevent both off. I'll leave the default 5 seconds, and then the asserted controls that I want to be subject under this safety rule are the two controls that I have, right? I want to make sure that this rule applies to both, and the rule configuration is going to be of type at least, and my threshold of 1, right? Because I only have 2, and you could have more than 2 routing controls as a part of your control panel. But because I only have 2, I know I want a minimum of 1 turned on, or at least 1. So I'll go ahead. I'm going to create that. And so now I have that safety rule, right? If I go here, and then let's say I am that engineer, that operations engineer that's coming in here, and maybe I don't know what I'm doing. I think I just need to turn both off before I turn the other one on, right? Because we're trying to fail back. If I confirm and change that traffic routing rule, I get that validation exception error that we were talking about, right? Telling me, hey, this isn't abiding by that safety rule that you've set. So sure enough, I do want to go back to the console and at least show you here this the AOB traffic monitoring that we had. Sure enough, we're down to 0 requests for US East 1 and up back to our over 150 count of requests on US West 2. And with that, I'll go ahead and then just change this back. We'll fail back to US East 1. Let me confirm that. You could see I'm abiding by my safety rule. I was able to fail back. And sure enough, right, if Miguel and I or yourselves, right, can test with the URL, you'd be able to see that that our mission critical application is back on US East 1. And with that, Miguel, I'll hand it back to you.
All right. Any questions out there while we're switching over here? All right, so wrapping up here, I just pasted all of these into the chat so that all of you can copy and paste those. A couple things wanted to share. There's a very nice blog out there talking about Route 53 disaster recovery, and it addresses those topics of control plane and data plane for Route 53 and provides some best practices there. And then for the tic-tac-toe application, there's a blog that shows you how to build that from scratch with all of the support for application recovery controller. And even better than that, there's 2 public sites out there that have both Terraform and CloudFormation code for it that'll allow you to build it from scratch if you want to do that on your own. And then the last thing I mentioned is there's a workshop that we have where if you want to get some hands-on with this, you can work with AWS or your partner and go through a workshop either as part of a disaster recovery immersion day, or if you just want to focus on the recovery controller, you can do that. So with that, I'll open it up for any other Q&A or informal comments or anything else. One last important thing, at the end of all the links there's a survey. So if you could please click on that, it takes about a minute to fill out, and just give us some feedback, tell us what you like or you didn't like, and these help us improve these sessions and help make future ones better. All right, I'll stop sharing here. So any questions out there, comments?
I think comment for me, I had initially kind of written off the application recovery controller just because for some reason I had thought that it just dealt with, EC2 ALV. Hence my question, right? So, pretty significant learning for me tonight is, some of the serverless use cases I work with would absolutely benefit from this. Taking some of the techniques shared early on in the presentation around the design of, disaster recovery capable solutions, will help kickstart that. So thank you. I know for me it was very beneficial.
Yeah, thanks, Patrick. Yeah, the readiness checks can definitely apply to those serverless workloads, and also for the routing controls, right? What's important that we suffered through some pain back in December, right, with what we call the LSE, the large scale event, especially the one on December 7th, is it impacted US East 1, and that's where the control plane for Route 53 lives. So what application recovery controller gives you is that level of control across 5 different regions. So if by some unfortunate event something were to happen like that in the future, where US East 1 would be impacted as a whole region, with application recovery controller, you still have the ability to make those Route 53 changes. And that was the thing to keep in mind is if you had all your configuration in Route 53 defined and everything configured, and you didn't need to make any changes, then it all worked well as far as Route 53. But there were customers that in the middle of that LSC wanted to make changes, and that's where it was impacted with the control plane. So that's what Route 53 gives you as a benefit.
Now, and I would add to that too, Miguel. What I see is customers prefer sometimes to have that failover mechanism be manual, and that's where they've also fallen into that, especially in the December event.
Yeah, that definitely that's one thing we've noticed too, right? It's easy to think of a scenario where something just fails, like a whole AZ or a whole region, which like we've never had a whole region fail like completely, but it's those like gray events, right, where something hasn't failed but the performance is poor, or maybe some services are having a challenge, and then you want to make that call manually. One other thing that I didn't get to mention is you can set up CloudWatch alarms for the readiness checks, and also for for any failures or anything like that with them, so you can be notified there. And also the other common question is, what if my application wants to send a signal as far as a readiness check, right? What if my application has a state where it says, hey, I'm ready to take traffic. And you can handle that with the readiness checks by having a CloudWatch alarm readiness check. So if your application is ready to take traffic, it can put up a CloudWatch alarm, or it can take one down, depending how you want to do the logic. And that can be one of your readiness checks. So within that dashboard, you get your feedback from your actual application. All right, that brings us to the end here. So thank you all for your time. If you think of anything else, you can feel free to reach out to us via email or the Slack group out there. And happy to be here with you, and looking forward to future sessions.
Absolutely.
Thank you so much, Jimmy. Thank you, Miguel, for joining us tonight and presenting, and thanks to everyone else for joining as well. Enjoy your nights. Thank you.
Good night.
All right. Thank you. Good night.